Hi dears, today we can see some properties in algebra. That is how to find the ring, integral domain, unit, field, characteristic for some sets like set of real numbers, rational numbers, integers and so on. So before moving to that, let's see what about the conditions for ring, field, integral domain, so on. So here the first one is the definition of ring. So a structure R plus dot is called a ring under the operation plus and dot. Let's see the elements of these elements, that is plus from R cross R to R. So R cross R means you know that this is a Cartesian product, right? So the elements are ordered pairs. So here you can see ordered pair AB to A plus B because the operation here is plus. So this belongs. So A plus B belongs to R and AB belongs to R cross R, right? So understand this. So this is the element belongs to R cross R and this is the output belongs to R, right? The same way here also, this is the element belongs to R cross R and this is the element belongs to this R under the operation multiplication. So what are the conditions needed for to be a ring, set to be a ring? So for that, addition is an abelian group. These four properties must be there. That is abelian group, associative, zero element, that is additive, identity, then inverse, then commutative. So for a ring, the first property, addition, is an abelian ring. And the second one, associative under multiplication, and the third one, distributive law under multiplication and addition together. Okay, so here multiplication over addition and multiplication. So these five properties must be there for the ring. So the first property, addition, is an abelian group, right? So if I am taking R means R plus is an abelian group. The second condition, multiplication under associative. Associative is true under multiplication. And the third condition, distributive over multiplication and addition. Okay, here you can see two properties are there. Here you can see. Okay, these three conditions satisfied, then we can say the required set is a ring. So let's see how to find the field. So for that, you can see the definition of field or the conditions of field. So this is the condition for field, associative of addition and multiplication. So for addition, associative, you have to take for addition as well as multiplication. The same for commutative, plus and dot should satisfy, and additive and multiplicative identity should be satisfied. And for inverse, the same, multiplicative and addition. And distributive, satisfied for multiplication over addition. Okay, these conditions satisfied means we can say the concerned set is a field. But for the ring, we must know that addition is an abelian group, and the second one, multiplicative, for only the associative, and the third one, distributive, possible for the addition and multiplication, right? So see the difference between these two. Here associative possible for both addition and multiplication, commutative for both identity, inverse is for both, distributive, multiplication over addition. So these are the conditions for field. And next you can see integral domain. So the integral domain means it is a commutative ring with unity and no zero divisors. Okay, so for the integral domain, you need to find three properties. First one, is it a commutative ring? The second one, it is a unity, and the third one, it has no zero divisors. In some problem, for finding the integral domain, just we can find only the third property alone, whether it is a no zero divisors or not. Accordingly, you can decide whether it is an integral domain or not. Okay, so because other two property itself, if you find unity, automatically commutative ring is obvious. So the third one is the compulsory one need to find for the integral domain with no zero devices. So this is one of the result. So here a ring is the bigger one, right? Bigger. So which contains commutative ring, and that contains integral domain, and which is contains GCD, greatest common divisor domain, that contains unit factorization domain, and that contains principal ideal domain, and which contains Euclidean domain, and which contains field, and last algebraic closed fields. Okay, so ring is the bigger one which contains integral domain, and that contains GCD, and which also contains UFD, unique factorization domain, and that contain principal integral domain, and that contain Euclidean domain, and which contain field. Okay, so ring is the bigger one. Let's see the sets. So the first set is a plus dot, which is a ring. So for that you have to check all the conditions for the ring. And for the field, so here Z plus dot is not a field, and whose characteristics is 0. The unit elements are only 1 and minus 1, and it is an integral domain because it is a commutative ring with the identity already you find out here. So it has no zero devices, so that it is an integral domain. Similarly, it is a chart, so you can understood easily. Q plus dot is a ring as well as it is a field. Then it is not an integral domain and the characteristics is 0. Then R plus dot is a ring as well as field. The characteristics is 0. But for the unit, you can see Q or C. For that, every non-zero element is a unit element. Okay, every non-zero element is a unit element for Q or C. Then C plus dot complex is a ring, field, characteristics is 0. N is a plus dot. So it is not a ring, not a field, not an identity, integral domain, as well as there is no unit element and the characteristics is 0. And one thing, it is an integral domain if it has no identity. If the set has no identity, then it is an integral domain because we have to check for no zero devices, right? So if it has no identity, it is an integral domain. And for this Zn plus circle n dot n, it is a ring, and the characteristics is n, and here you can see it is a field for n equal to prime, and not a prime means it is not an field. Then it is not an integral domain, n not equal to p, and if it is equal to p, then it is an integral domain. Unit element, if GCD of an equal to 1, then we can say the particular element A is called a unit element. So this is a chart you can understand easily for the sets to be a ring, integral domain, field, unit, and the characteristics. Thank you.